Right. So very quickly, in a very specific order, I was waiting for my transformer to show up for my uh, isolation transformer on my bench. This would be a 1-to-1 ratio isolation transformer that I found through Jameco, and then subsequently purchased on Amazon for the bargain basement price of $50. And I was all excited because it showed up, and then I opened it and found, I'm not even concerned because at this point, this is how it came out of the box. Nice, brand new transformer. Let's see if we can. So I'll mash down. I'll have to pull this apart and see if it actually messed up the windings at all. Do some ohms measurements. So not sure if I'm just going to throw this up as a hey, watch out for this, or this might be part of a larger clip. But yeah, brand new transformer. That's how it showed up, and that's the way she rolls.
Autobots, roll out. We roll.
Not those kind of transformers. The power transformers, output transformers, signal transformers, control transformers, isolation, step up, step down. These are the types of transformers that we want to discuss. Now, most of you guys know exactly what a transformer is, and you can go ahead and skip ahead. Maybe I'll put some directions down at the bottom, but it's a good time to take the opportunity for the new guys to say, okay, do you really know what a transformer is? Do you have some questions about it? I'm going to put some links to some better videos, but it seems to me like this is a good time to talk about, what the difference is between this isolation transformer and a normal, what we normally see. So let's talk about a transformer. What does a transformer do? Well, it's going to transform a voltage into another voltage. Sometimes it's going to be to make it more useful in the sense that it's going to step up that voltage, like this transformer, or it's going to step down that voltage. We'll talk about how it does that in a second. But what we're looking at is an isolation transformer, which is basically the simplest type of transformer. So if we take a transformer, if we take a piece of wire and we make some loops in it, like so, 1, 2, 3, 4, 5, and we bring it back out, we just put a coil and some wire, which isn't all that great. But if we connect this wire to voltage, AC, and in North America here we're running about 115, 120 volts, and in my house it's about 120. So if we hooked it up to 120 volts VAC, and this wire is the hot or power, and this side was the common or neutral, then this would be a 120 volts VAC, which would not be anything spectacular. It would just be a wire carrying voltage. But if we made an identical wire on the other side, exact same thickness, right, an exact same number of coils, 1, 2, 3, 4, 5, okay, and then we basically wrap those coils around a iron core like this. Let's just say this is an iron core. Then essentially, because of the wonderful properties of induction, we are inciting electrons in the second coil to move, right? And that's the science behind this is, above my pay grade to explain properly. I will leave that to someone else. But essentially, that's what a transformer is doing. And then by changing the number of coils on the secondary, then we can change the amount of voltage that we are using. So in a 1-to-1 transformer, if we have the same thickness wire on the secondary side and we have the same thickness wire on the primary side, we will wind up with 120 volts AC on this side of the coil. Now, the last thing is, when you're looking for an isolation transformer, you're going to see this a lot, VA. And it's, well, why isn't it just in Y? Well, because it's the load that they're going to put across. It can be different types of loads. It can be resistive, they can be capacitive, they can be inductive. There's a lot of different, which will change the math on what the actual wattage output is. So to just make it simple, because they don't know when they manufacture these general purpose transformers what you're going to do, they just give it that VA kind of rating, which is voltage amperes, and maybe we'll link a video to that as well. So these are the main types of transformers that we see when we're working on the bench, although again there's more, but the isolation transformer, that is one of the most important things. And if you think about it in this term, without getting into the whys, it's electrically isolated from mains voltage, which means it's electrically isolated from mains ground. But there's some traps we're not going to get into. There's probably better videos on where you could wind up with a path to ground via the safety on some of these isolation transformers if you buy them. Now, that's one of the reasons why I bought this transformer. I thought it would be a good idea. So let's talk about what we're going to test while we're sitting right here, just to get rid of this so that it's not quite as confusing. I'm gonna test, and we'll choose red for our probe. Okay. I'm going to test between this wire and this wire. I'm going to do that first. Well, probably on the primary side, and I want to make sure that I have, very little resistance on it. Continuity. I want very low resistance. And I want to make sure that I don't have continuity if I were to come over and probe here, from here to here. Okay, I don't want any continuity there. Now, if I probe these 2 points, I would want continuity, but I don't want it between this wire and this wire. And I certainly don't want it between this wire and, let's say, here at the iron core. I want to make sure that these are electrically isolated. Number one, your transformer won't work. But number two, it becomes unsafe. So we're making sure, and this can happen on either side, these wires are generally covered with an enamel. It's very thin. And when that enamel, when the transformer gets too warm, it can cause a breakdown on that enamel when it's been bent too many times, wiggled back and forth. It really doesn't take much, honestly, to start to wear through that enamel, or to give a path for electrons to flow, thus creating a closed circuit between the wire and the transformer. So, and if we have one on both sides, we have a completely it's a fire waiting to happen. Actually, on either side, it's really a fire waiting to happen. But so that's what we're going to do, is we're going to check to make sure that we have continuity across this coil, that there's no breaks in that wire. We're going to look for continuity across this coil to make sure there's no breaks in this wire, and then we're going to make sure that we do not have continuity between this wire and the transformer, this wire and the transformer, and these two wires all independently. We want to make sure that everything is electrically isolated. That's essentially how we're going to test for function in a transformer. It's not going to tell you anything about the values. There's a whole other test, and that's for a whole different video. We're just talking about the basic function of the transformer. So let's go ahead and go back to our transformer. Okay, so what we just talked about, essentially, hopefully this all comes out on camera. This is our transformer, and these are our secondary windings. This is actually the side that we're going to connect the load to, and you can see the damage that was done during shipping, which is we're not real happy about. But inside we have our, better angle on that, we have our wiring where our connectors are on top. You can see we have a wire right here that goes to our fuse, and then the other one just goes directly into the coil. So essentially, these are the two sides of the coil. This is one wire, and then this is going to be on the secondary. And then we also have the same thing on the primary side. We know it's the primary because the cord. So because they have this fairly well insulated, what I've noticed, not because of that, but just an aside real quick, this is right, the corner that corresponds, it's just bent a little bit, and it doesn't look like it actually hit. It looks like these things did their job. The spindle, it's done its job. It kept the wires from getting impacted, but we still want to make sure that electrically it's okay. So first, I'm just going to test the primary side, and since I don't have a spot really to go to over here that's not insulated, I can just go right to the end of the cord. All right. So right across here. And we're not making good contact right here. Might also be time for a battery change. Yeah, see how it's charging up like that? It almost seems like there might be a capacitor on there. And there is a capacitor on there, actually, a safety capacitor. Yeah, I think it's time for a battery change. What's going on here? So, I'll tell you what, just to make it a little bit less confusing, let's put it in this mode. Everybody loves this mode. Diode mode, right? So diode mode, less than 50 ohms. Beeping mode, less than 50 ohms. We're going to get a beep. Okay, so if we come over here to our cord, right on the prong, we got a short. And I can tell by the sound of that, the battery's getting low. So we come over here to the other side. We can do the exact same thing, except we don't have any prongs to go to on our plug. We're actually in our, where our connectors hook up. So let's just go ahead and, okay. So that's good. The question becomes, do we have a short between here and the transformer? No, we do not. So check the other side. Of course, we're not going to have anything. Okay, and then if we do the same on the other side, we can go right to the plug and look for a short to our transformer. And there's nothing. And then last but not least, we're going to go coil to coil. So we're checking to see if there's any continuity between the two coils, and there is not. So we could have had a break, a tear in the insulation, that enamel on one coil or the other touching the transformer. And because these coils are actually stacked right on top of each other, this is what you call an IE transformer. And I hesitate to say it, but I'm sure you could find this information somewhere. You can actually make your own transformer, wind your own transformer. If you remove this outside plastic layer, these iron cores underneath here, there's a little weld on each end, this end, and then down here on this end. And you can grind that off. And once you've ground that off, you can unstack all these little I's and E's and take this out. And you could rewind your own coils. Now, that is one way that you could, in theory, and I have to be very careful here, if you wanted to make your own isolation transformer, and I'm not telling you to do this, I'm saying don't do this, but if you wanted and you were desperate and you don't listen, one of the things that one could do is they could grab an isolation transformer or a transformer that is a 120 input and an identical 120 input. Let's say out of maybe you get a few power supplies out of some stuff that got scrapped and they both had good transformers in them, but you didn't have any use for that output power on the secondary. Maybe you said, no, I need an isolation transformer, and I had these two identical transformers. Now, identical means the nomenclature matches, the manufacturer is the same, it's all the same, and you've verified that the resistance in the wire is the same and that the diameter of the wire is the same. If that is the case, you can kind of sort of assume that you probably have the same amount of windings. It's not a guarantee. That should be the case. So you would be able to take the primary off of each coil, or the secondary off of each coil, and the primaries off of each coil, and then put the primaries, the 120 and the 120, on the same core. That would give you a 1-to-1 ratio transformer. And then you'd have to re-weld this. Again, I don't recommend it because there's too many ways that can go wrong. too many things can happen, and if you're not careful, you could cause a fire. In addition to that, there's safety in here. Most of these things have thermal protection, and now in the form of a small capacitor, a safety cap in here, or an NPC that will disconnect the circuit to keep it from drawing amperage when it gets too hot. So if you don't do it. Okay. In addition to that, we have a fuse on this one. So the next question is, now that we've talked about transformers and we're all caught up, and I'm going to go ahead and put a marker in here so that everybody knows, okay, this is where we're going to go when you're done. In order to make this thing okay, I don't know if I want to take the time to bang this back out. This is going to go into an enclosure, and we're going to add the dim bulbs, which basically are acting as a current limiter set. We're going to add that to the same enclosure. I haven't really got it down in my head how I'm going to do it, but I've got a lot of ideas right now, and I have some things. I have a voltmeter, panel meter that came in. I'm waiting on a panel amp meter and some other stuffs, neon bulbs. I have ideas. We're going to see what I decide to cobble together on the fly. So I think maybe I could probably put a tool in here and straighten this out, but it's really, really bent. I don't think I need to worry about it, but because I don't like these connectors anyway, what I might do is just go ahead and eliminate this and find a different way of running the wires back in here, and just making a direct connection to the secondary output wires, and just eliminating this. I don't need it. It's this is a one and done kind of thing. I'm only going to use this transformer for one thing, but I will keep the fuse because the fuse is good, but I'll have to pull that out of the housing, find a slightly different way of putting it in there, and I might get a hammer and just kind of find something to kind of bang this back out with, rough it up and throw a little bit of paint on it just to make it look not as horrible. I don't know. We'll find out. We'll see what I do. But essentially, electrically, this thing is okay. It's safe to use. If you're looking for a review for this Jameco transformer, I mean, I guess the transformer's probably not going to be that bad. We'll have to do some testing on it to find out, if it's worth a darn. And if it's actually getting the advertised voltages, or power output. But as far as, it's a good sturdy iron core transformer. That sucker weighs a lot. These things are cheap. I expect them to be a little flimsy for $50, but that was really flimsy. It bent inside of 2 boxes. It got hit. It must have got hit, smacked pretty hard. And I've read some reviews where they say the same thing. It's just, there's like a lot of pitting in the metal underneath. They didn't do a lot with the finish. Wouldn't expect them to. Again, it's really cheap, but it's even cheap for cheap standards when it comes to these covers. And this plastic, electrically it looks okay. I don't see anything. These are a little on the thin side, but for the price, it's 300 volt amps, so it's not really supposed to carry that much current. I think it's going to be adequate. I don't see any major issues with it. I'm not happy about this, clearly, but and as far as the hardware goes, you can kind of see it sitting back here. The bolts are a little bit long, I believe. Here's one. So go ahead and just pop this back together. I'm not going to tighten it up because I want to work with this cord on here on this side. Ugh. Okay. So this would go on like so. Like so. And it's not pressing up against it. It seems like it took the impact and it kind of moved one of the spindles. It's got a red washer right here. We'll back side. So I'll go ahead and slide them. I'm orienting them the same way that they were when they came out. This will go right through here. And then there was another red spacer. They're not, I don't know what these things are. Some kind of insulative material. So it seems to me that these stick out a little bit further than what they need to. I mean, I'm that's kind of being picky, but I mean, I don't like loose things in electrical chassis where it looks like stuff could snag, you know. But now that it's kind of got its shape back together, these would be the feet. So, I'm not sure how well that comes out on camera. Essentially, you know, bolts go through, and then so you have your brackets for which to mount into a cabinet or whatnot. So this is the only, which my understanding is that this sticker is a new addition. A lot of people said, and when I was looking on the catalog information, you didn't see this. You know, 120 volts AC, 60 hertz, 120 volts AC, and you'll notice on the output they do put 2.5 watts, and then isolation at 300 watts, which is going to translate basically to 300 volt amps. So, you know, that sticker is an add-on. They apparently haven't been doing that the whole time. So it's a hefty little, but and it's mostly in that iron core, but that's okay. That iron core, honestly, that the width of that core almost makes me think that this is probably either or. It's probably a 50 hertz, but it's marketed here for 60 because we use 60. Because usually when you have the 50 hertz transformers, they usually have that larger iron core, because the frequencies are lower, and that gets into a whole nother thing. Point being is, I think it's going to be useful for what I want, which is an isolation transformer. And this cord just, I mean, non-polarized feels ridiculously cheap. I think we're probably gonna replace the cord on this. So, yeah. Sorry, non-polarized. Ridiculously cheap feeling. Yeah. So we'll probably replace that, but the like I said, hefty little sucker we got going on here. So, I think I'm gonna call it quits on this one. I'll probably go ahead and do a build on the supply, and maybe we'll add this into it, make it one big huge video. Well, the world's the oyster. Something about a pearl, or a girl named Pearl. Dog, whatever. All right, until next time, be nice to each other, be safe, don't mimic the monkey.